Welcome. In this video, I'm going to go over whether or not this infinite series converges or diverges, and we're also going to determine if that convergence is absolute or conditional. If you're in my online calculus course and your notes do not show a little n cubed there, please just write that in manually. Remember, your teachers don't get editors. Okay, so let's look at a couple things. The first is we're going to look at whether or not b sub n is decreasing. And so I'm going to make it really clear. A sub n is equal to negative 1 to the n plus 1 over the square root of n cubed. And b sub n is just equal to 1 over the square root of n cubed. So the first thing we're going to look at is b sub n decreasing. The next thing we're going to look at is the limit as n approaches infinity of b sub n. We need that to be 0. And then finally, we're going to look at, does the sum, or does this series, the absolute value of this series, converge or diverge? So the idea is these first two criteria, if we have a decreasing series here, or excuse me, a decreasing term, and the limit's equal to 0, then we know the series is convergent. Criteria 3 determines whether that convergence is absolute or conditional. If it converges, then the convergence is absolute. If it diverges, then our series converges conditionally. All right, so let's take a look at this. For the first one, b sub n, I'm going to say let f of x equal 1 over the square root of x cubed. X is a real number. The only difference is these are integers. Otherwise, I'm not going to get into more details than that. So this can be rewritten as x to the negative 3 halves power. F prime of x is equal to negative 3 halves x to the negative 5 halves power. So that's negative 3 over 2 times the square root of x to the 5th. So long as our x is greater than 1, well, greater than 0 really, which implies greater than 1. So long as x is greater than 0, this will certainly be negative. Try any number you want in here that's greater than 0. 1/2, 1, 20, 100. This will give you a positive value, and you're going to divide a negative value by it. So this is greater than 0 for all x greater than 0. Oh, excuse me. This is less than 0. What am I saying? This is less than 0 for all x greater than 0. So I know that b sub n is definitely decreasing. All right, let's look at number 2, this limit. So the limit as n approaches infinity of 1 over the square root of n cubed, that is definitely equal to 0. Okay, so we've checked off 1 and 2. So we definitely have a convergent series here. That is, this is convergent by the alternating series test. Now we need to know if that convergence is absolute or conditional. So let's take a look at number 3 here. So for number 3, I'm going to look at the sum from 1 to infinity of the absolute value of our original series. Well, there's more than one way to show that this series here converges. You can use the integral test, say, but frankly, it's really easy to identify this as a p-series. And if you don't see it yet, I'm going to rewrite this one more time. This is the sum from 1 to infinity of 1 over n to the 3 halves power. In this case, p is equal to 3 over 2, which is certainly larger than 1/2. Excuse me, not 1/2. It's certainly larger than 1, my bad. So since p is greater than 1, we know that this series converges. All right, so let's write out our conclusion. In conclusion, so this series, our original series that we started with, an alternating series, is absolutely convergent by the alternating series test. And before I close this video, if this feels really unsatisfactory towards you, oops, let me check. If this feels unsatisfactory to you, just remember that right now you're not computing anything. You're really just arguing with mathematics. So here's our conclusion. We laid the groundwork for our conclusion with these arguments. So 1, 2, 3. We made 3 points, 3 arguments that demonstrated our conclusion. So just consider this your introduction into arguing with mathematics.